So these technical issues can have a kind of a frustration that was quite visible and apparent in all your comments that I was going through. But I hope that now everything is sorted, and I hope that now we can have the continuous regions based upon the air masses and based. Good. So we were talking about the types of source regions based upon the air masses and based upon the different areas. We had seen that how the air masses have been classified, whether they are drier. So when they generally end up lying over the oceanic areas, you will have the air mass or referred to as the maritime, or M is associated. Or whenever you have the air mass which is drier over continental area, you have C which is associated. Now, there are a couple of anomalies in that case, in that situation. Here, when we talk about it, let's suppose, so we have seen that you have various different types of air masses. Now, in all these different types of air masses, we have seen the position of them as well. Now, there is one discrepancy, that is, you will never find CE to be present. That is, continental equatorial is not present. So there are a couple of reasons for no continental equatorial to be present. You only will find maritime equatorial to be present. No continental equatorial is present in that region. Now, why is that? So there are a couple of reasons. First reason is that in the region of equator, you don't find a very large continental area. In the tropics, you will find large continental landscapes to exist. But over the equatorial region, you don't have very large land areas, mostly dominated by the water bodies. Wherever you have, for example, in South Asia, you have some amount of land area. In Africa, you have land area. But understand, when we talk about the region of South Asia and various different island regions, now island regions will indicate what? Suppose here you have a kind of an island. Let's suppose this is an island of sorts. Okay. Suppose this is an island. But the island will also indicate a maritime property in terms of the air parcel and the behavior of air above it. Why? Because when we say a maritime air mass, why is it that we refer to an air mass as being maritime? That is purely because of the presence of moisture, high amount of water vapor which is present. That is why we classify it as maritime. So over these island regions, because of convection from the surrounding water bodies, you will always experience significant amount of rainfall here also on a daily basis. So here again, no continentality in the air parcel will be observed. You have some land areas up around the region of equator in both Africa as well as South America. Now, in both of these areas, now yesterday we had seen, when we were talking about the aspect of convectional current, we had seen that in equatorial areas on a daily basis, in the late afternoons and in the evenings, on a daily basis, that is, you will end up receiving significant amount of rainfall. Rainfall will be quite significant and significantly happening through the day. So that is why even in these areas, you will observe, even in these regions, daily occurrence of rainfall, occurrence in rainfall. Now, this daily occurrence of rainfall, what will it do for the moisture level in the air? Moisture level will be high, the humidity level will be high, right? Now, if the humidity level is high, you cannot declare an air mass to be continental, because, as I told you, continentality is associated with the dry conditions or a dry characteristic. Now, in this case, as the moisture level is high, so you cannot have that as a continental air mass. So, continentality is always associated with dryness. I will write it down here. Continentality is always associated with dry conditions. Always. Now, in the region of equator, we don't have dry conditions. That is why no continentality in terms of nomenclature. In equatorial areas, no dryness, humidity level is high, and hence no continental classification. I hope that is understood. So that is why in the classification of air masses, you will find all various different types of air masses, but you will not find continental equatorial, and that is because of the moist conditions of the air parcel, which is prevalent all around. Now, after this, we come to the portion of fronts. What are these fronts? What are the classification of fronts? Where they get created? Why do they get created? What is the impact of it? Now, when we talk about fronts, so basically, fronts is an English terminology. It is not a geographical terminology per se. But when we talk about the fronts and that English terminology of it, what is the implication or the meaning? You would have heard the sentences that the general led the battle from the front. Now the battle is being fought at the front or battlefront in general, right? What is that front? The edge of something, the fringe of something. So, whenever we have, let's suppose, from the polar area, let's assume that you have cold air parcel which is coming in, very cold air parcel. And then from the tropical region, let's suppose you have a warmer air parcel which comes in. So you have warm air and cold air. Now, please understand that even in terms of their horizontal aspect, they can extend for hundreds of kilometers altogether, thousands of kilometers also in many of the cases. Okay, so we are talking about very large parcels of air coming in front of each other. Now, these will have a kind of a homogeneous property in terms of temperature, they will be cold. This will have a homogeneous property of sorts in terms of being warmer. Warmer air will always occupy a greater amount of volume. We do know that. Now, ideally, in your ideal scenario or in your mind, you would recreate a scenario where cold air comes, warm air comes, they will meet together. You have a cooler air mixture which is created. That is what your mind will think about it. But that is not what happens. In actuality, these air parcels and these air masses will have different properties. They won't be able to mix immediately. And they will form distinct zone of transition between them. Where if as an individual you are standing here, you will experience colder air. And if as an individual you are standing here, you will experience warmer air. As you move from here to here, you will experience that difference in temperature. So there is that distinct zone of transition that is created. So that distinct zone of transition, that is what is referred to as a front. Okay. So that is what we refer to as a front. That is the distinct zone of transition where you have air parcels of different properties interacting with each other. That is what we have as the front. So here, when two different air masses meet, the boundary zone between them is called a front. Now, in the case of the front, on one side you will have a colder air, on one side you will have warmer air. Now, warmer air is always going to be very light. And this is going to be very heavy, the cold air. Okay. Now, so when you have a heavy object and or a heavy particle and a lighter particle coming in, suppose they collide, what can happen? You can always envision that the warmer air will be pushed or will be rising up, right? because the colder, heavier air will very much stick to the ground surface itself. The colder, heavier air won't be lifted up, but the warmer air will be lifted up, isn't it? So you will always experience that the warmer air rises above it. Okay. Now, how is it that this front is created? A front is created whenever you have from one region warm air coming in, from one region cold air coming in. That is when a front is created. So, for example, if we consider the planet, so we do know that from the polar areas, you have cold air coming in. Now, it is not going to be the case that everywhere the cold air will have the same stretch. Maybe in certain areas, the cold air comes further southwards. In certain areas, the cold air remains northwards itself. Similarly, when we talk about warm air, it will not be the case that warm air is also uniform. In certain areas, it will have a lower limit. In certain areas, greater limit. That can always end up happening, isn't it? So, in that case, whenever there will be an interaction and that formation of a zone of transition, there will be creation of a front. That is how a front will always be created. So, that is the creation of a front. That is what we refer to as frontogenesis, or the birth of a front. So, the process of formation of a front is referred to as frontogenesis, the birth of a front. Now, the fronts will mostly occur in the mid latitude. Mid latitude means between 45 to 60 degrees north and south hemispheres. That is where the frontal formation will be observed and will be experienced. And that is because it is in these areas where you will have the warmer air from the tropics and the colder air from the polar regions. That is where they will end up interacting. Okay. So that is where warm air from the tropics interact with the cold polar air. Now, here you can always apply the common sense and a common sense of logic here. Greater the difference between the warm and cold air temperature, more stark will be that zone of transition. That difference, if the temperature here is very low, that temperature here is very high. So that means the zone of transition created will have very sharp conditions of weather, etc. Isn't it? So that is where, when the difference is very high, be it the tropical air might be very warm, or maybe in certain years the polar air might get very cold. So in those conditions, the front, or the front which is created, is much more stark, is much more well defined as well. Now, let's suppose another condition. Let's suppose that here you have the mid latitude, the cold air has come in, the warm air has also come in. But by the time that they come to this region, let's assume that they have lost their energy. They are not able to move any further. It can happen. It can happen that the air in itself has lost its energy, isn't it? So it cannot move further. So it stays there in the same region for more than 2 weeks, more than 2 to 3 weeks. That is around 21 to 28 days, it stays in the same region without movement, or even around 15 to 21 days, it stays in the same region. Can we say that when it consistently is confronting each other, can we say that you have a warm air gaining some property of the cold air and cold air gaining some property of warm air? We can say that if it stays in the same region for a long period of time, each of them, they will start gaining each other's properties, isn't it? If we can say that, can we go a step further, and can we also have a conclusion that this air then will be able to freely mix with each other? Maybe a 1 degree Celsius air might not mix with a 45 degree Celsius air, but a 23 degree Celsius air will be able to mix with a 25 degree Celsius air. When both of them have come to a kind of a common ground, the air will start mixing with each other. We can say that if they stay in the same region for a longer period of time, they will gain each other's properties and they will start to mix. Now, if that is the case, can we say that the zone of transition, that in itself starts getting mixed and starts getting destroyed? There is no distinct zone of transition if you have uniform condition. What is the zone of transition anymore? So in that situation, can we then come to a conclusion that the front will no longer exist? The front will be dead. Any issues with that assumption? No? Perfect? Good. So that process where, or that stage when the air stays in the same region, gains each other's properties, and you have the death of a front where the air is ready to mix with each other and there is no distinct zone of transition anymore. That is what we refer to as frontolysis, or the death of the front. So that is what we refer to as frontolysis. Okay. So frontolysis is, that means death of a front. So that is where we have, as the air stays in the same region for a longer duration, it gains each other's properties. And that means no distinct zone of transition anymore. And you don't have a zone of transition, which means no front. So the birth of a front, frontogenesis. Death of a front, frontolysis. Okay. Now, where is it observed? In the mid latitude. Mid latitude refers to 45, 40 sometimes even. So you can think about even 40 degrees for that matter. 40 to 60 degrees, north and south. Okay. So that is where you will experience this zone of transition getting created. So it can stay over a same period for a very long period of time. It can end up moving. Why does the air move? Why will the air move at all? Due to creation of different pressure zones, due to difference, or due to creation of a low pressure and a high pressure, that is a pressure gradient. That is why the air moves. So let's suppose the air has come till this distance, and after that there is no further low pressure to attract it. That is when we say, or the high pressure itself, let's suppose, has weakened. It is the high pressure which has been driving these winds or this air. So let's suppose the high pressure has weakened. So there is no pressure or no force driving it anymore. So it will stay in the same region, right? It will stay in the same area. And what do you have in that case? You will observe that the air continues to interact with each other. It is staying in the same region. It is interacting with each other, gaining each other's properties, and that is frontolysis. It is near the subpolar low pressure zone. Yes. Okay. Now, what is being explained in the figure above? That is the best question that I have had. Are you having the session on mute in that case? If you have no clue what is being talked about in the figure above, is it on mute in that case? Are you just trying to gather from the written text? I would rather suggest to you, please don't keep it on mute. This is not a kind of a monologue or a political lecture that we are delivering. Okay. Now, that is about the frontal formation. Again, I will repeat here. Frontal formation is when you have air parcels of distinct properties, different properties, when they confront each other, they create a zone of transition. You will have, if you are, as an individual, you are standing here, let's suppose. Now, as an individual, if you move to this particular area, as you move from here to here, you will experience very distinct conditions. And that is where you say that there is a transition in terms of the air masses. So if I take you back a couple of slides here, I hope you don't ask me again that what are you talking about in this slide as well. So observe here, there's a zone of transition between the cold air and the warm air. Now it is not on a straight line, is it? It is not on a straight line. In certain areas, the warm air comes further southwards. In certain areas, the cold air goes further northwards in the southern hemisphere and vice versa in the northern hemisphere. So these are your zones of transition. So in these zones of transition, you will observe that there is a distinct, when two distinct air masses meet, there is a boundary zone differentiating those air masses. And that is what is regarded as front formation. So formation of a front, formation is frontogenesis. Then dissipation of a front. Vivek, is that understood now? What is front? Is the basic understood, or is there no clue still what is going on? Dissipation of a front. From where are you feeling that there is no clue? Frontolysis. From where is it that it has started becoming a bouncer? It is not that I would start revising and repeating the entire class here. Okay. The last slide. Okay, you can take a look at the last slide later on as well. Don't worry. The next portions that we will talk about, I will ensure that we lower the level of it so that you are able to understand. Just understand that when you encounter different air parcels, they will not readily mix with each other. They will end up gaining each other's properties overall. And that is what we have as the front formation. Okay. What happens when if a person stands on fronts, what will happen? Okay. See, this is like very creative type of questions. So it is this area that you see here. Please understand this is not so narrow that you have one leg on the cold air and one leg on the side of the warm air. This is never going to be that thin an area. Even this thickness is going to be significant, and even this thickness is going to span for many kilometers in itself. Okay, so even that region of a front can span for many kilometers altogether, many kilometers. So you can be standing right in the one portion of the front, the other portion, or the other extremity of the front. Now here, when we talk about the fronts, different types of fronts are present, and that is the stationary front, the cold front, the warm front, and what is also referred to as the occluded front. So when we talk about the types of front, it basically represents the different conditions where we have cold air on one side, warm air on one side. So when we talk about, for example, I'll give you the detailed aspect of it as well. When we talk about the stationary front, stationary means what? Something which is static, something which is stagnant, something which is not moving at all. It is very static there. So that is a condition when the air parcel has come from a polar region, the cold air. I hope we are clear in that from the from the polar area you have cold air coming, and from the warmer area or the tropical area you have warmer air coming in. So let's say the air has reached there and cannot move any further. That is the limit till which the air will move. Then you have a stationary front. Now, what if, let's suppose, you have the cold air which pushes further. Now, if the cold air pushes further, if the cold air is active, what will happen to the warm air? Now, warm air has greater volume, it is lighter in weight as well. Cold air is heavier, has got lesser volume. So, suppose you have a warm air here and you have a cold air coming in. As it pushes in, it will suddenly lift up the warm air. The warm air, as we have seen earlier, will be significantly lifted up very suddenly because the warm air is lighter. So, such a condition where the cold air is active, that is your cold front. Cold air is active. Now, what happens in the other condition? Let's suppose you have cold air which has reached here, warm air which is continuously pushing in, warm air has reached here, and then the warm air is further moving into the region of the cold air. What will happen in that case? Will the cold air be pushed up or will the warm air rise up? What do you think? Warm air rises? Perfect. Why? Because why isn't it that the cold air is pushed up in this case? Because always warm air is lighter, cold air is heavier. So colder air will be sticking to the ground. Warmer air being lighter can be thrown up very easily. So here the warm air will be thrown up, but it will rise up very slowly because it is the warm air which is moving. So imagine if this is the portion of the cold air. If the warm air is coming, it is very easily going to rise up the region of cold air. On the other hand, if the cold air is moving in, or let's suppose the cold air is moving in, here you have warm air, cold air suddenly pushes up the kind of warm air which is present. So in the warm front, warm air mass is active. Then you have what is referred to as the occluded front. Now, what is the meaning of occlusion here? Are we having any idea about the meaning of occlusion? Occlusion is also an English terminology. What is the meaning of occlusion? Occlusion basically refers to the act of closing, when something is closing up. So this is the stage when the front starts closing up. Generally observed in the case of a temperate cyclone, this is when the front starts to close up. So yes, blocking is perfect. So a stage when the front closes up. Okay, let's take a detailed look at each one of them, starting with the stationary front. So when is it that a stationary front is created? A stationary front is created when from one region colder air has come in, from one region warmer air has come in. Now both of them, they start, or they have come into that position, but they don't have enough energy to push into each other's areas. Imagine you have, let's suppose, two armed forces. Take the case, and I'm just giving you an analogy, guys, just for your better understanding for that purpose. Imagine two armed forces, one of India, one of our neighbor Pakistan, as happened in December 2001. You would be aware of that when we had a parliament attack. Now, immediately, India, as per Operation Parakram, it started a large scale mobilization of our armed forces at the border. And from all the various parts of the country, the armed forces, they rushed to the border. Pakistan also started deploying the forces to the border. But so much of time and energy was consumed upon reaching the border, no further action. So they took a halt there. Everybody was confronting each other. Same thing can happen for air parcel as well. All the energy is consumed in reaching up to in front of each other, and there maybe they have lost their energy due to weakening of the high pressure in itself, or due to dissipation of the low pressure where they were going. It might happen, anything can happen. So that is when they come in front of each other, but they cannot proceed any further. They lie there for some time. That is the condition of a stationary front. So here, a stationary front forms when a cold front or a warm front stops moving, right? So this happens when two masses of air are pushing against each other, but neither is powerful enough to move the other. So you have one of them, the cold air, and the warm air. Okay, cold air and warm air. Now they have come in front of each other. They don't have energy to move into each other's territories. That is a stationary front. Now from here, only certain possibilities can happen. It can happen that over a period of time, maybe the cold air region gains some amount of energy and the cold air starts pushing in. It can also happen that over a period of time, the warm air gains energy and starts pushing. Thereby, when the warm air pushes, it can create a warm front. Cold air pushes, it can create a cold front. Or what can happen? None of them gain enough energy. Both of them, basically, let's suppose both of them, they stay in the same region. None of them gain enough energy. They both stay in the same region. Now, when they stay in the same region for a longer period of time, can we say that they can gain each other's properties? They can gain individual properties. They will start mixing with each other. They will start homogenizing with each other. And in that case, what do we have? Dissipation of the front or frontolysis. So, if in any place you have a stationary front in existence for a very long period of time without much, and here very long period of time we refer to maybe more than 21 days or 28 days, something in that range. So, if for more than around 3 to 4 weeks you have a stationary front which is in existence without moving, you can always experience dissipation of a front or frontolysis. Okay. So, if in a region conditions of stationary front exist for a long period of time, we have air starts mixing with each other, and then we have dissipation of the front. Okay. So that is the case of the stationary front, and that will lead to creation of a condition of frontolysis. Okay. Now, then we come to the portions of cold and warm front. What is it? Now, here the easiest way to understand it or remember it, cold means cold air is active. Warm means warm air is active in that case. So when we have a cold front, so that is formed when the cold air is active, and it is the cold air mass which pushes into the warm air mass. Now here, few of you might have the very basic question or a very basic doubt, that why is it that one air will be active, or why is it, or where is it that they are getting this energy from? What is the source of generation of this energy? So understand always that the horizontal movement of air parcel is dependent on a pressure gradient. As long as there is a high pressure, it will continue to drive air movement. If the high pressure weakens, the air movement will be stopped. As long as you have a low pressure, it will attract the air movement. If the low pressure weakens, the air movement stops. Now, in the mid latitudes, the cold air is driven from which high pressure? Let me see. Have we revised anything or not? In the subpolar regions, the cold air is driven from which high pressure? Very good. It is the polar high pressure. Warm air is driven from which high pressure? When we talk about the subpolar areas, warm air is driven from which high pressure? The dynamic subtropical high pressure. So if these high pressures for some reason or the other, some year or the other, for some months or the other, if they weaken, can we say that the air's movement and its energy will also reduce? Isn't it? They will not have enough energy. Let's suppose again they get strengthened, they will push against each other. So that is how you have the movement which is decided, or that is the dependence on the movement. Now, here a cold front is created when it is the cold air which is pushing in. Cold air is more active. Now, when the cold air pushes in, and we have discussed about this, let's suppose you have warmer air, and this column of, or this pen represents a column of warmer air. Now, as the cold air pushes in with a significant energy, or suppose, now what will happen to the warmer air? It will suddenly be lifted upwards, isn't it? The warm air being lighter is thrown upwards significantly. So when this happens, warm air being lighter is thrown upwards quite significantly, isn't it? Now, that will bring about vertical rise of warm air. Now, the warm air is almost being thrown vertically. So, can we say that condensation will keep on happening at multiple different layers and multiple different levels? We can say that because the warm air is thrown up violently vertically upwards, we can have a conclusion by simple logic that is the warm air is simply being forced upwards, then it will have a condensation at different levels depending upon the moisture level. It will have a condensation in multiple levels. So we can say, or we can have a conclusion that if the condensation is happening at multiple levels, we can always experience a multi-layered vertical cloud formation to happen. And which is that cloud type? Cumulonimbus. Cumulonimbus has got a significant vertical height associated with them. Condensation would have happened at multiple levels. That is when the cumulonimbus gets created. So this will lead to creation of vertical or multi-layered clouds, right? And these multi-layered clouds, mostly cumulonimbus. Okay, observe here. The warm air is being pushed upwards. It is the cold air which is coming in. So the warm air, which was lying in its own place, very happy with its own existence, has suddenly been pushed upwards. Now, as it is suddenly being pushed upwards, you have multiple layers of clouds getting created, and that is cumulonimbus. So, what kind of weather phenomena will we observe here? What is the weather phenomena associated with cumulonimbus? Very heavy rainfall, correct? Very heavy rainfall. Thunderstorm, very correct. Thunder and lightning. Right? We can experience that, or we can basically observe that. Now, can we say this is a kind of a frontal rainfall? Because this rainfall is being created or is being caused purely because of the formation of a front. Can we classify this as a kind of a frontal rainfall? Perfect. So, all of you who had a doubt about frontal rainfall, I hope now you are clear about that, that what is this frontal rainfall, right? So, this will be associated with frontal rainfall. Now, another factor I want you to understand and I want you to identify with this. So, in this region, the warm air has been pushed up. So, if I represent a schematic diagram for this, cold air has come here. So, the warm air which was there, warm air has been pushed vertically upwards. So, this is a warm air. So, in this region, can we observe a frontal inversion? A frontal inversion can we observe here because warm air is on top, cold air is at the bottom. Frontal inversion can we observe here? Laksh, you had been asking this question about frontal inversion for some time now. What is inversion? Inversion is a condition where you have warm air on top, cold air at the bottom, isn't it? Here you have warm air at top, cold air at the bottom. But why is this condition created? Because of the frontal features or the features of the front. That is why we can say you have frontal inversion as well. I hope this is clear. How clouds are being formed? Clouds are being formed because here you will observe warm air is being forced to rise up. As the warm air is being forced to rise up, as it rises up, suddenly, with altitude, its temperature will reduce. With the reduction in temperature, it will attain saturation, relative humidity will get higher. If it rises further, that is when it will get colder, then it will condense. And that is how cloud formation will be observed. Is that understood now? Good. Now, then, yes, sometimes hailstorms can also be observed. Gulam, see, understand that you are free to do that, but understand that the more you keep on pushing and postponing it and without revision, then you are looking at a kind of a condition where the entire subject will be left behind. But then again, it is up to you. Janvi, in one region there is little rain falling, and in other region there is a heavy rain falling. Sometimes you feel transition in that case also. So, is there a specific term? In one region there is light rain falling, in another heavy rain falling, and sometimes we feel trans. No, there is no specific term for that. It basically depends on the wind pattern and the density or the thickness of cloud. Tornado is also created because of the mixing of cold and warm air, and that is a vertical mixing of cold and warm air that brings about a circular movement. So, that is basically the case of tornado. Is this portion understood? Good. Why geography is not called as science? It has it have its rules. Then why not science? Because you have a significant portion of humanities involved here as well. All these portions of what appears to be science for you as of now, I understand there is a significant amount of technicality associated. I have refrained from using any technical terms till now. Trust me for that matter. And all of you who are exploring various different books would be knowing the amount of technical aspects and the formulas associated. Open up any complicated or any of the standard books. Those of you who have, a few of you have also had your masters in geography, you would adhere to the fact or attest to the fact that we are keeping it without usage of any technicality. All of this is important. Why is it that I wanted to clear civil services examination? I wanted to be an IS officer in my life. And I am studying about warm air rising up, cold air sinking down. How is it relevant for my preparation of civil services? I'm sure most of you would be asking this question almost on a daily basis to yourself every time that you take a look at this subject, that it is better to study the portion of polity what is happening in parliament. There is so much amount of entertainment. Home minister is saying something, leader of opposition is saying something. That will be relevant when I become IAS officer. How will this be relevant? I understand that predicament as well. But please understand, all these phenomena, they end up influencing the climatic conditions of a region. They end up influencing the causation of disasters in a region, cyclonic circulation in a region. Once the climatic conditions, now many areas such as Mongolia and the Mongolian region or Central Asian region, many of those areas, you'll find that they are so much in the interior of the continents that there is availability of rainfall only because there is a front formation. Otherwise, those areas would never have received rainfall. The only reason why they are not the driest of the deserts in the world is because of front formation. If imagine Central Asia would have been a complete desert, life would have been very different there. The type of occupation that people would have carried would have been very different. But because you have some periodic rainfall because of frontal formation, that is where you have large scale pastoralists who rear large amount of animals, large number of animals who only graze on the grasses. So pastoralists are in large numbers, nomads are in large numbers. So how these factors end up influencing human life, and how that human life is needed to be understood in order to influence a decision making. It is for that reason why you need to understand these aspects. Okay, so please try to, whenever you have that kind of a frustration, and I'm sure many of you would be asking yourself this question, that why did I choose this kind of a aim in my life? I would have been better if I would have studied maybe MBA or something. At least I wouldn't have been exposed to all these aspects of lapse rate, etc. But all of this is very temporary as long as you are getting confused in the basics. And this will happen when you are reading it for the first time. It is very natural for you to be confused in this basics. And that is why, for the first time that you revise, that is why I might be very harsh sometimes when I tell you that please revise, otherwise no, I won't entertain your questions, is because I want you to be very comfortable. The more you revise this, even the basics that we have covered in the class, the more you revise it, the concepts get clearer and clearer. And then the entire picture that you will be able to paint, that will be unparalleled. Please understand, 10,000 candidates sitting in the mains examination would have read the same NCRTs that you would have read, but not everybody will have the ability to interlink the various concepts together. And that will come with the critical thinking approach. That is what we are trying to inculcate in the class. Okay, I hope that is taken up in a positive aspect. Okay, now, okay, you want a break? Fair enough. Okay, I'll give a break. Let's not have that oppression anymore. So we'll take a break and we'll be back in by 7. I hope that is fine. So break till 7 and be back, because there are important concepts that we are going to cover today. Okay, let's be back. When will we study economics? In the economic classes, you will study economics, my dear friend. As simple. That is where you will get the written portion of it as well. Okay, so many of you, when you seek the portion of or the written text in general for definitions, etc., kindly refer to the additional reading materials. Okay, so now we come over to the portion of a warm front. So, how is it that a warm front gets created? So, warm front, in the case of the cold front, we had the cold air which was active. In the case of a warm front, we have the warm air which becomes activated, and the warm air has significant energy. So, in this case, you have a cold air, or over a region, let's suppose you have the over any particular surface, let's suppose you have the cold air. And from the other region, let's suppose the warm air is coming in. Now, as this warm air is coming in, it will not immediately vertically rise up. It will end up getting risen eventually, because in both the cases, it is the warm air in majority which gets risen up. Some amount of cold air is also uplifted, but that is not in significant proportion. But then in majority of the portion, it is the warm air which gets uplifted. So as the warm air gets uplifted, in the cold front, we had seen that the warm air was vertically uplifted, but here the warm air very gradually gets uplifted, very gradually. Okay, so that is where you will find that the warm air very gradually starts rising up. So in this case, again, as the warm air starts to rise up, you will experience condensation happening here as well. But the condensation which will happen here will happen at various different levels spread over a larger area. In the case of the previous situation, we saw that condensation is happening in the same region in multi-layers. Here, you will have the condensation happening spread over a larger area, isn't it? So that is where here you will observe various different levels of clouds getting created. So this will be dominated by the stratus and nimbostratus types of clouds. So warm air, as it pushes in, warm air rises up over a larger distance. Isn't it? It rises up over a larger distance. So you have stratus or nimbostratus and stratus type of clouds. Now, what can be the weather associated? The weather phenomena associated with this. Weather phenomena that you can associate with it will be a light prolonged rainfall, a continuous rainfall. Lightning will occur, but you won't have that violent lightning which will happen in the case of cumulonimbus. Even if an odd event of lightning happens, that will happen within the cloud itself. That is a general phenomena of nimbostratus that we studied. So here you will observe continuous moderate rainfall, okay? For a prolonged duration, you have that continuation of rainfall. Now, this rainfall is created why? Is it because of the convection current? No. Is it because of the mountain present in between the air movement? No. This rainfall is again because of the front formation in itself. So can we say that here also you will have frontal rainfall? So that is a frontal rainfall that you will experience. Now, if you consider any stretch or any air column here, for example, on the ground surface, you have colder air and above it, you have warmer air. That is again a situation of temperature inversion. Temperature inversion is when you have a negative lapse rate, that is referred to as a temperature inversion. So here also you have a temperature inversion, but this temperature inversion is not created because the surface has lost heat, or because there is a valley which is present, or because of any other reason. This temperature inversion has been created purely because there is a kind of a front. So that is again what we refer to as frontal inversion. Okay, so that is how a warm front is different from a cold front. Now, after this, we come to the portion of an occluded front. Occluded front is basically when a front starts to close in from all various different directions. And that is what is referred to as an occluded front. Generally experienced during a cyclonic formation, generally experienced whenever you have a temperate cyclone in existence. So that is basically an occluded front. So for this, let us understand a scenario. Let us think about the planet here. Now let's assume cold air, and the cold air mass is coming from this region. Let's suppose from the other side warm air is coming in. There will be certain areas where the warm air will be pushing further. There will be certain areas where the cold air is pushing forward. So you will have initially the creation of a front with a cold air on one side and warm air on the other side. Okay. Now, in this situation, you will observe that this cold air here, if the cold air is active, it will be cold front. If the warm air is active, it will be warm front. But over a period of time, on the ground surface, whether it is a cold front or a warm front, on the ground surface, which kind of air will be present? What do you think? Cold? Isn't it? On the ground surface, cold air will be remaining. So this front will be subsumed. From all sides, cold air will start coming in. And eventually, this front will be deformed slightly like this. Then after that, it will be deformed somewhat like this. And eventually, you will have a process where the front starts getting closed. So as the front starts getting closed from all sides, that is what is referred to as an occluded front. So occluded front is when the front begins to close from all different sides. Front starts to close in. So cold air is something which will be dominant. Now these are the multiple different stages of a temperate cyclone that we will study later on and a few moments later. But observe here that this is what represents a kind of a stationary front. This is where the front gets deformed, as in one area warm air starts pushing in another area cold air starts pushing in. And again you will observe that this is leading to a condition where the shape of the front in itself is getting deformed. Observe how the front then begins to close in from all sides. And here, observe this side portion, the side in this particular portion. Now you will observe that on the ground surface around the front from all areas, the cold air is coming in. So on the ground surface, the front is closing in, lifting the warm air upwards. Be it a cold front or a warm front, the warm air will be lifted upwards. That is where, as the front begins to close in from all sides, we refer to that as an occluded front. Now, in these conditions, when you have an occluded front, what can we have as the next stage after an occluded front? Can we say that eventually in this particular area, the front will cease to exist anymore? And in this particular area, can we say that eventually it can lead to frontolysis? That is the dissipation of the front. So eventually leads to dissipation of the front and that is going to lead to frontolysis. Okay, so in simplest of the terminologies, over a period of time, understand that whenever you have any frontal formation, you will have certain areas where the cold air starts pushing in, certain areas where the warm air starts pushing in. So the front over a period of time gets deformed. Okay, so that deformity, as the cold air pushes in, warm air pushes in. So let's suppose here the warm air is pushing in this area and here you have the cold air pushing in this area. So over a period of time, you can have a kind of a deformity in the shape of the front itself. This will further get exaggerated as this pushes in. So eventually it will lead to a more narrowed and a peak frontal shape, right? So this is the top view that we are taking here, guys. So eventually the front will be closed in from all sides. It will be the cold air on the ground which will surround that particular region from all sides, and that is where the entirety of the region which was experiencing the front formation, there the front is closing in from all sides. So that final stage where the front starts getting closed in from all sides, that is what we refer to as the occluded front. Okay, so occlusion of a front is the event of closing in of the front. So that is what we have as the case of occlusion. Okay, occluded front can eventually lead to death of a front. So observe these tiny images here. Here also you will observe basically that, observe here, initially you have cold winds in one region, warm winds in one region. Now over a period of time you will observe that cold air will push in certain areas, warm air will push in some areas. Observe how the front starts getting deformed. Eventually it will have a shape which is significantly narrowed down. That is when the front closes in from all directions. Okay, so that is what we have as the occluded front, where on the ground surface you will have the cold air which is present in this region and warm air will be lifted upwards. Okay, now we have the portion of cyclones. Now this is a portion very important for your examination, because cyclones, they are always associated with very heavy intense rainfall, significant amount of thunder, lightning, and also it is associated with very strong wind movement, destruction, devastation follows a cyclonic formation almost everywhere. So what are these cyclones? Something that you hear almost on a daily basis, or not on a daily basis, at least on a monthly basis or a regular basis, that there is a formation of a cyclone here or a cyclonic formation has happened, this is what it will lead to, etc. So what is a cyclone? So in simplest of the terms, cyclones are, or cyclonic region is an area of an intense low pressure which ends up generating a circular movement of the wind, or generating a circulation of a wind in a round fashion. So these are areas of intense low pressure, areas of very intense low pressure involving a circular motion of the wind. Okay. Circular motion of the wind where? Around. No, India does not experience tornadoes. Around the low pressure. Now, cyclones in itself is of two types, depending upon where it is created. Now, that is, the classification is done based upon the regions where you experience them or expect them. That is the temperate cyclones, and also tropical cyclones. India experiences significant amount of tropical cyclones, whereas temperate cyclones, they don't end up getting created in India. Why? Because India is a tropical country and here you don't have a frontal formation. So for this, you need a frontal formation. Formation of both of them, their individual properties are also distinctly different from each other. The only thing that is common in them is that they are areas of intense low pressure. Now, why is it that you have a circular motion of the wind? Because of the Coriolis force, which we will take a look into. Now, these are areas of intense low pressure. So what will be the opposite of it? So you also have what is referred to as anticyclones. Anticyclones will be the exact opposite of it. So what is it? So when we say anticyclones, these basically refer to areas of intense high pressure. Areas of intense high pressure. High pressure means, in the case of high pressure, you have sinking air. In the case of low pressure, you have rising air. Now, for rainfall to happen, do you need the sinking air or do you need a rising air? What do you think? For the rainfall to happen, for a cloud formation to happen, you need the rise of air or do you need the sink of air? Good. Always for a cloud formation, you need rise of air. Whenever you have a sinking air, means no condensation will take place. So these are always underscored or associated with dry conditions and an absolute lack of rainfall. Associated with dry conditions and a lack of rain. Whereas here you have rising air, and that rising air in the case of the cyclones, that will lead to very dense cloud formation, very heavy rainfall will be associated with it. So when we say cyclonic and anticyclonic circulations, so the wind circulation around a low pressure is called a cyclonic circulation. Around a high pressure, it is called an anticyclonic circulation. It has got to involve a circular movement of air, whether that is a rising circular movement or a sinking circular movement. So, for example, in a region of an intense low pressure, suppose intense low pressure. Now, if you have an intense low pressure, winds will be coming in from all different sides. Now, they will be bending because of the Coriolis force. Coriolis force is induced due to what? Due to the rotation of the planet. So that Coriolis force will lead to the bending of the wind. As the air rises up, it will be rising up in a circular manner. So here you have the rising air. Here you have the sinking air. But the circulation achieved in a case of a cyclone, in a case of an anticyclone, the circulation is very different in northern and the southern hemisphere. And rather than learning clockwise or anti-clockwise circulation, it is very easy to understand purely by logic. If you know that the winds will deviate in the rightward direction in the northern hemisphere and the winds will deviate towards the left in the southern hemisphere, that basic aspect is more than sufficient to understand the circulation of a cyclone or an anticyclone. So cyclone is an area of intense low pressure. Low pressure. Now let's assume the case of the northern hemisphere. Let's assume northern hemisphere. Now low pressure means winds are going to be attracted here. Very intense, very high low pressure, not a normal low pressure. Low pressure means winds are going to be attracted here from all different directions, isn't it? But because we are in northern hemisphere, the winds will be bending to the right here. The winds will be bending to the right. Isn't it? In the northern hemisphere, the winds will bend to the right because of the Coriolis force. So if, let's say, as an individual, I send you to stand in the center of the low pressure as a part of the punishment, that go and stand in the center of the low pressure. Now, if you are standing at that low pressure and you are reporting that what is the direction of the wind that you observe around yourself, what is the direction of the wind that you will be reporting? So around that low pressure, you will observe that the wind movement is generally like this. In general, the wind movement will be like this. Now that is clockwise or anti-clockwise? It is anti-clockwise. So hence, the cyclonic circulation in the northern hemisphere happens in anti-clockwise direction. So you have anti-clockwise direction circulation. Now the opposite of it. Let's suppose we have the southern hemisphere. Let's suppose we consider the southern hemisphere. Now in the southern hemisphere, if we consider the low pressure, now there you will find that the winds will be attracted from all directions here as well. But here, rather than right, you will observe a leftward bend for the winds. So all these winds will be bending in the leftward direction around that low pressure. Now again, if you carry the same exercise standing in the middle of the low pressure and you are asked to report the direction of the wind movement, you will observe that the wind movement is in this direction around the low pressure. What is that? That is clockwise, isn't it? So that is basically the clockwise circulation that you will observe in the southern hemisphere. The image that you see on the screen is basically a case of a tropical cyclone as observed from space. So you can observe the intense cloud formation where you will observe, this is a tropical cyclone we'll study, this is referred to as the eye of the cyclone. Observe how the circular wind movement has impacted the condition of the cloud formation as well. So for a cyclone, a circular movement of air is almost prerogative. It is very important. Only then will you refer it to as a cyclone, right? A cyclical movement. Now, then after that, we come across the condition of an anticyclone. Now observe, in the case of a cyclone, as observed from space, you will observe that there is significant cloud formation because there is a rising air. But in the case of an anticyclone, you observe a complete lack of cloud in one region, because this is where the winds are sinking from all areas. The winds are actually sinking onto the ground surface. So these are intense high pressure. Intense high pressure. Now from a region of intense high pressure, will the winds be attracted to the high pressure or the winds will be sent out from the region of high pressure? What do you think will happen? From that region of high pressure, will the winds be attracted inwards or will the winds go outwards? Sent out. And here also the circulation will be different in the northern and the southern hemisphere because of the rightward and the leftward bend. So if we consider the northern hemisphere, let's consider a center of high pressure. Now in this case, what you experience is that the winds will be diverging out. But because you are in northern hemisphere, the winds will be turning to the right, bending to the right. So the winds will be bending to the right over a period of time. Why? Because of Coriolis force. Why? Because of rotation of the planet. So if you were to stand here and observe the movement of wind around that high pressure, what is the movement in general you will observe? A movement like this. So that is why anticyclone in a northern hemisphere represents a clockwise circulation. Very good. Clockwise circulation. When we talk about the southern hemisphere, in the case of southern hemisphere, you have a high pressure. Why in high pressure winds are outwards? Because we know that winds always blow from a high to a low. So from high pressure, always the winds will originate because that is the region of an excess. And low pressure is the region of deficiency. So winds will always be attracted towards low pressure. These are very basics, guys. Something that you would have revised in the previous session if you have opened up the previous ones or attended the previous sessions. So in the southern hemisphere, the winds will originate but will bend in the leftward direction. They will always be bending in the leftward direction, isn't it? So what is the circulation that you achieve? A circulation which will be achieved will be in what? It will be anti-clockwise. So southern hemisphere and anticyclone is associated with anti-clockwise circulation. Now, is this portion of circulation something that you can arrive by logic? I hope you don't need to learn this. Is this understood purely by logic? Right? Yes. So please observe that aspect itself. Please don't end up rectifying it. Many of the candidates learn it up. The moment you start learning things, that is where you create a scope for negative marking to happen. As long as you are able to apply your logic, there is a very little chance of negative marking in the prelims. Okay, so in the areas of anticyclone, you have sinking air on the ground. So this is nonetheless, all those who still would like to rectify some of the aspect, this is for your revision purpose. So cyclone is a low pressure at the center, anti-clockwise in northern hemisphere, clockwise in the southern hemisphere, and the opposite stands for an anticyclonic circulation. Okay, now after this we come to the temperate cyclone, and then we will move over to the portion of a tropical cyclone. So coming over to the temperate cyclone, temperate means it is experienced in the temperate regions of the world. What are the temperate regions of the world? The mid latitudes, that is between 40 to 60 degrees. That is where this temperate cyclone will be created. Now, these are the regions of intense low pressure. Now, here, the cyclonic circulation is created because of frontal formation. How, why, we will come to that. But this circulation is created, or this cyclone is created sometimes when the front gets distorted quite significantly. But here, listen to the next statement very carefully. Not every front will develop into a cyclone. But for a formation of a cyclone, a front is a must. I will repeat. Not every frontal formation will lead to a development of a cyclone. But for a temperate cyclone to occur, a frontal formation is a must. That means that not every time that a front develops will it develop to an extent of a temperate cyclone. It might dissipate at the stage of the cold or the warm front or the stationary front itself. But then no temperate cyclone will be formed without the formation of a front. So this is observed due to frontal formation. That is a must. Now, where is it that the frontal formation happens across the planet? It is observed in the mid latitudes, isn't it? Between 40 to 60 degrees, that is where you observe this. So this is where observed in the mid latitudes. Okay, that is where it is observed. Now, so this is associated with frontogenesis. Associated with frontogenesis. Now, can this be observed in India? Will this get created in India? Perfect. This is not created in India. Why? Because we are going to observe this only in the mid latitudes, mid to higher latitudes. In lower latitudes in the tropics, you don't experience this. Not observed in tropics. Observed in tropics. India, however, gets impacted by a form of a temperate cyclone which develops over Mediterranean. We will study in the next couple of modules, and that is what we experience as a Western disturbance. So that is something we will study. But then this is not primarily formed in India. Now, this is associated with the frontogenesis. Now, frontogenesis is going to happen. Now, again, as the very famous dialogue goes, chronology is important, as is used by many of our politicians as well. So here also, please adhere to the chronology of the aspect of the logic here. When we say that it is associated with frontogenesis, can we say that frontogenesis will be more when the difference in temperature between the cold and the warm air will be more? Whenever there will be a greater difference in temperature of the cold and warm air, we will have greater amount of frontogenesis, right? We can say that. Perfect. So here, now in which season do you think frontogenesis is, or there is a greater difference in temperature between the cold and the warm air, or the polar and the tropical air? There will be greater difference in temperature in which season, summer or winter? Okay, let me tell you what actually happens, or majority of you have referred to it as summer. So let me tell you what happens. So let's consider the temperature difference in the winter and summer. In the tropical regions, right, and the polar area. Now the tropics during the winter will experience a temperature roughly around 20-25 degrees Celsius, right? That will be the temperature even in winter months in the tropics. So it will be 20 to 25 degrees Celsius on an average. I'm taking an average. Now, when we say the polar region in the winter, temperature will be how much? Temperature will go to the range of minus 50 degrees Celsius, minus 45, minus 50 degrees Celsius easily, isn't it? So here we can experience a temperature of even minus 50 degrees Celsius in certain cases. Whereas when we talk about the summer condition, in the tropics, in general, the temperature is around 30-35 degrees Celsius, isn't it? So let's say 30 degrees Celsius on an average. Where, yes, you have certain areas which indicate very high temperature, but those are very continental areas and small regions. In general, 30 degrees Celsius. Now, The polar area during the summer season will again experience negative temperature, but around -10, -15, isn't it? Let's assume -15 degrees Celsius. Now, what is the difference of temperature in this case? Around 60 to 75 degrees Celsius. What is the difference of temperature in this case? So when is it that the difference of temperature is going to be more significant? During the winter, isn't it? That is when the difference in temperature is going to be very high. So basically, difference in temperature is more dominant during the winter, hence more frequent in winter. In winter months. Is this understood? Why it is more frequent? Now, if the frontogenesis is basically more frequent, how come 60 to 75 degrees? Okay. These are simple calculation, guys. Please understand what is the difference if you have 25 degrees Celsius in one place, in another place you have -50 degrees Celsius. What will be the difference in temperature between these two areas? Again, I will repeat, you will never be allowed to appear for the mains exam if your CSAT is weaker. And CSAT is becoming tougher. These calculations, Chandrasekhar, tell me the difference of temperature between 25 and -50. Please don't make me go for a kind of... Is this difference of temperature -25? Understand this, my dear friend. Simple arithmetic it is. This is 0. This is 25. This is -50. What is the difference here? Here, if I have to calculate the difference, or in simple terms, 25 minus of -50 will be how much? 25 plus 50 equal to 75. Is that understood? Ten degrees Celsius. How do you get the difference of 10 degrees Celsius in this case? Geniuses in maths we are. Okay. See, if we are spending our energy in studying this aspect, that 25 minus -50 is how much, then I'm sure there will be many of the complicated concepts we are not able to touch. So let's try to move forward. So frontogenesis is going to be much more frequent in the case of the winter months. That is where it is going to be much more frequent. So can we say that the temperate cyclone will be much more frequent during the winter months? So cyclonic formation in this case will be more frequent in the winter months. Is more frequent when in winter months. Now apply another logic. Okay? And by again logic, I attach a caveat. Apply the logic. Okay? Don't just flow with the aspect. Apply the logic here. We are talking about the difference in temperature. Now, if I ask you, in different regions in the mid latitudes, if I compare northern hemisphere and southern hemisphere, where is it that you will have a more stark difference in temperature created? And where is it that you will have a kind of a uniform temperature created? So in northern hemisphere or southern hemisphere, where is it that there will be a greater difference in temperature created? What do you think? Perfect. So you will observe a greater, starker difference in temperature observed in the northern hemisphere as compared to southern hemisphere. Why is that? Because northern hemisphere dominated by land masses, so that is where the temperature will be changing quite substantially. Land areas can get very hot in the tropical regions, land areas can get very cold in the polar areas. So in the northern hemisphere, there will be starker difference of temperature. So there can we say that there will be greater amount of frontogenesis in the northern hemisphere as compared to the southern hemisphere. I hope we are comfortable with that. Okay. So frontogenesis more frequent in northern hemisphere. So that means greater frequency of cyclones. There will be a greater frequency of cyclones. Where? In the northern hemisphere. Perfect. No confusion up till this point of time in this basic portion. Good. Now, again, understand another aspect. Let's suppose I consider the planet here. Now, suppose this cyclonic circulation of the wind happens in the mid latitudes. Now, once that cloud formation that you observe in the screen, once that gets created, so they will be influenced, or the entire cloud formation can end up getting moved because of the permanent wind system. So this temperate cyclone impacted by the permanent wind system, the entire cloud formation, etc., will move in which direction? East to west to east, north to south, south to north. What do you think? In mid latitudes, okay, better to write it down. In mid latitudes, which is the wind system which is prevalent? Permanent wind system. Which is the permanent wind system which is prevalent? You have westerlies. So hence, the entire disturbance moves from west to east. So cyclones move from west to east. Even if you are able to understand these basic portions, that is also sufficient for the general studies questions that appear. Okay, even this much basic, if you are able to understand, more than sufficient. But let us explore more. Let us try to understand more. So a temperate cyclone is also referred to as a mid-latitude depression. Depression refers to a kind of a low pressure. So because a cyclonic circulation is created due to low pressure, hence mid-latitude depression. Extratropical cyclone, because happening beyond the tropics. Frontal depression, because created due to a front. Or a wave cyclone. Why it is referred to as a wave cyclone? Because oftentimes when you observe the formation of a front, the front oftentimes represents a wavy shape, a wavy pattern, hence referred to as a wave cyclone. Now, temperate cyclones are active above mid-latitudinal region between 35 to 65 degree latitude in both the hemispheres. The direction of movement is west to east due to westerlies, and is more pronounced during the winter season. It is along these latitudes that the polar and the tropical air masses meet and end up forming fronts. Okay? Now, after this, let us understand the various different stages for the formation, various different stages which are involved in the formation of a temperate cyclone or the existence of a temperate cyclone. So first of all, it all begins with a frontal formation. And again, I will reiterate that for the development of a temperate cyclone, a front is a must, but does not mean that every front will develop into a cyclonic circulation. So first of all, you need to have, for the formation of a front, what do you need to have? You need to have air masses of different temperature confronting each other, coming in front of each other, isn't it? So initially you have the front formation. Initially the beginning phase is created by the stationary front. Stationary front is demarcated by this symbol, not very much important for your examination. So here initially you have a stationary front. Now in this stage the cold air is present, the warm air is present. Now ideally what can also happen is that neither the cold air progresses into the warm region nor the warm air progresses into the cold region. It stays in the same region for a longer period of time. If it stays in the same region continuously for a longer period of time, both the air masses will start mixing with each other. And then what you have? A dissipation of front at this stage itself can also happen. Okay. But sometimes these fronts, they get deformed because maybe the cold air tries to enter into the warmer territory, the warm air tries to enter into the colder territory. And that is when initially you will observe that the front starts to get deformed. So you have activation of the front. And again, understand the chronology. Chronology is very important here. So activation of the front starts to happen. Cold air is pushing in from one area, warm air is pushing in from another region. So the stationary front starts getting deformed. Stationary front starts getting deformed. Now, as the stationary front starts getting deformed, as the cold air becomes active here and the warm air becomes active here. Now, in this region, what kind of front will be created? The portion that I have highlighted. What kind of front will be created here? Beautiful. Very good. You will have a cold front getting created because it is the cold air which is getting activated. In this region, what kind of front will get created? A warm front will get created because the warm air is getting activated, isn't it? So this leads to simultaneous formation of cold and warm front. Leads to simultaneous formation of cold and warm front. Now, when you have in the same area a cold front and a warm front, now in both these cases, do we observe a rise of air or a sinking of air? Cold front, warm front. We observe a rise of air or a sink of air. What do you think? Always you will observe a rise of air. In both these cases, always you will observe a rise of air. Because if a cold front is created, significant portion of warm air will be pushed vertically upwards. Some portion of cold air will also rise up, but significant portion of warm air will be pushed upwards. In the case of a warm front, warm air will automatically start rising upwards, carrying some amount of cold air along with it, but warm air will be consistently rising upwards, isn't it? So in both these cases, what do we have? We have a rising air column. Rising air column is associated with a low pressure or a high pressure. What do you think? Rising air column. Always a low pressure. So, creates in the same region large columns of rising air. In the smaller area, large sections of rising air is observed. Now, when you have a large amount of low pressure which gets created, then what happens? So that leads to intense low pressure gets created. Is this portion understood? Why I am asking it again and again, guys, because trust me, I have referred to multiple different books in this area. All of you who have done your masters and your graduation in geography will attest to the fact that this is not something which is given in the books. In the books, you are being drawn, or in the books, if I tell you in the books how it is given is, you refer to the books also. You will find these kinds of images in one region, the small images that you see, and they will tell you that the cyclone gets created and a low pressure is formed. Why that low pressure is formed, how that low pressure is formed, nobody will tell you. So that is why I want you to understand the basics. Once you understand the basics of this, then everything else will automatically come to you. You will be able to create 150-word answer out of it. You will be able to create 250-word out of answer out of it. And the advantage that you will get as compared to your competition will be simply unparalleled. So I want you to understand. Same is the case with the tropical cyclone as well. When we talk about the formation of a tropical cyclone as well, that is in itself a very unique phenomena. So I want you to understand the very, very basics. Okay. So that is where, when we talk about it, basically the intense low pressure when it gets created. So that would do what? It would attract winds. Attract winds from where? From all direction. Wherever there is an associated high pressure, it will attract winds from that region, isn't it? So high pressure will be there from the polar region as well. High pressure is there from the tropical region as well. More winds will be attracted from all directions. That brings us into the mature stage of a cyclone. So in this, you observe you have a cold front here, you have a warm front here. Okay. So occurrence of both the fronts, both the fronts, directions, all directions. Now, also one basic factor I want you to understand is, in general, we have seen that there can be thermal high pressure, there can be a dynamic high pressure. Polar high is a thermal high pressure because it is created because of very low temperature in the polar region. Then when we say about the subtropical high, that is a dynamic high pressure. It is created because of the sinking of air. Always remember one fact, that thermal high pressure is always going to be much more stronger than the dynamic high pressure, much more intense as compared to the dynamic high pressure. Similarly, thermal low pressure is going to be much more intense as compared to the dynamic low pressure. So the thermal high pressure is created in the polar region. So that will start sending in more amount of cold air. More cold air will be coming on the ground. So slowly and steadily, the cold air will start surrounding this region. Now here, when you have both these conditions, this is a warm front. So I can also have this represented as somewhat like this. So let's suppose this is a warm front. Let's assume Thermal and dynamic high pressure we have already covered in detail in the previous sessions. Kindly revise them. We have covered in significant detail about the thermal and a dynamic high pressure. So let's suppose this is a cold front. Let's suppose you have a warm front. Now we have earlier seen that the conditions, the climatic conditions, the weather associated will be very different in the case of the cold front and the warm front. Meanwhile, as the air is being pushed up across this entirety of the region, the air is rising up. But the air won't be rising in a kind of a straightforward manner. The air will have a circulation and a revolution due to the Coriolis force. And that will develop around the entirety of the region. So that is where you will have the center of the low pressure around somewhere here in this region. And that is where the air will develop a cyclonic circulation as it rises up. But when we talk about the weather associated in this region and the weather associated in this region, so here you will have heavy rainfall, heavy and intense rainfall associated with a lot of thunder and lightning, very strong winds, very strong winds. And here you will have moderate continuous rainfall, associated wind movement will also be there, moderate wind movement. So in this entire region, a circulation will develop. But over the ground surface, can we say that on the ground surface you will have cold air here as well? On the ground. And here also on the ground, what do we have? Cold air itself. Okay, so the cold air slowly and steadily, be it a warm front or a cold front, the cold air will start to surround this region. The thermal high pressure is sending the cold air continuously. The warmer wind is being supplied from, and more warmer winds will be attracted from the region of the subtropical high pressure belt. More warm winds will be attracted, but all that warm wind will either be immediately vertically pushed up or will slowly and gradually rise up. So this frontal formation over a period of time, it deforms itself. Dinesh, my dear friend, you have never, I'm sure you would never have, or in case you have traveled to Europe or Northern America, there also you will experience that during the temperate cyclones, the strong winds that you experience, that is because of the cold front. As the cold front starts moving, that is when you experience. In India, you would never have experienced this entire process at all. Okay. So I hope you get that in perspective when you are relating it with your day-to-day life. So this basically starts getting deformed. Slowly and steadily, cold air surrounds this from all sides. And that is what is referred to as the beginning of occlusion. So here you have the cold front. So observe, you will have the dense cumulonimbus clouds here. And this is the center of the low pressure around which the winds are rising up continuously, forming that circulation. So this is the beginning of occlusion. So this is where the front, the cold and the warm fronts come very close to each other. Okay, so in this situation, the in the same area, let's suppose in the same regional spread, you will continuously be experiencing a lot of wind movement. Cold winds will also be experienced in these areas. Warm winds will also be experienced in certain areas. But nonetheless, heavy rainfall and wind movement, heavy cloud formation is a consistent phenomena in this, associated with a cyclonic circulation in general. Then slowly this develops further, and you have the late occlusion where it begins to close down. So in this, the front closes down. Front completely closes down. How? Because on the ground surface, the region is completely surrounded by cold air. Cold air. So eventually, if on the ground surface in this particular region of low pressure, if let's suppose you only have the cold air, so that means in that region you don't have any front anymore. So if you don't have a front anymore, the cyclonic circulation will come to an end completely. I will repeat, around the region of low pressure where the air was rising from all sides. Now, if at that region of low pressure, there is a uniformity of temperature of air surrounding it, because the cold air has come in from all sides. So that means on the ground surface, you no longer will have the existence of the front around that portion. So that means what? You will have a closing of the front, isn't it? So once the front gets closed, no circulation of cyclonic circulation will happen. So that is the end of a temperate cyclone. So eventually leads to frontolysis and basically dissipation of the cyclone. Okay, so these cyclonic circulations, when we talk about the formation of a temperate cyclone, for example, so these cyclonic circulations, they can actually extend, excuse me. So these entire disturbance in the cloud formation, as you can see, they will be spread over a entirety of the region of this frontal formation. And we know that the frontal formation is dependent upon the air masses. And we have already seen that air masses can extend for hundreds of kilometers in the cases. So the entire cyclonic circulation covers a very large area. The entire cyclonic circulation and the entire cloud formation created by this can have a distance or a diameter of close to around 1000 kilometers. 750 to 1000 kilometers can be observed. I will repeat the entire process one by one. So try to have that revision once again. So when we talk about the formation of a temperate cyclone, a front formation is a must. A temperate cyclone can never get created without the formation of a front. Now, once a front gets created, initially it is a stationary front where the cold and the warm air have come in front of each other, but neither of them are moving in each other's direction. At this stage also frontolysis can happen. But in certain cases where the cold and the warm air both have some amount of energy left, the cold air will try to enter into the region of the warm air and vice versa will also happen. So this leads to the distortion of the front. And simultaneously, you have the creation of the cold and the warm front. Now, in either of the cases, whether it is a creation of a low or creation of a warm front or creation of a cold front, both of them involve the rise of the air. So in both of them, the air rises in different proportions, but air rises nonetheless. So as the air starts rising up in both the cases, you have an intense low pressure which gets created. Now, due to that intense low pressure, air is attracted from all sides and it starts rising up around these frontal formations, but it will also, as the air is coming in, it will be influenced by the Coriolis effect. It will have its bending as it rises up. It will have a circulation. Now, in the region where you have a cold front, you will experience very heavy rainfall, a kind of a thunderstorm, violent weather activities, strong wind movement. In the case of a warm front, as we have seen earlier, you will have light to moderate rainfall, weaker wind movement in general because the warm air is slowly and easily climbing up. But nonetheless, in the entire region, you will experience this kind of a weather phenomena. Now, as we have that low pressure, you will have cold polar winds which are attracted towards that low pressure because polar high is a polar high pressure. So cold polar winds are attracted. So around the ground surface, these cold winds, they start to envelop that region. Slowly and steadily, in the region of the warm front as well, it will get deformed. Slowly and steadily, you will observe that the front starts to close. Eventually, it closes in the last stage, that is referred to as the stage of occluded front or the stage of the dissipation of the cyclone, because once there is frontolysis which happens, then the cyclonic circulation won't be in existence anymore. That is the aspect of the entirety of the temperate cyclone. This entire phase can last for 2 to 3 weeks, sometimes slightly more than that easily. It can last for that duration. And it will also be spread over a large area because it involves a large frontal formation. Okay. But in certain rare cases, what happens? Now, whenever you have this front formation and you start observing with the help of the satellite data that the front is getting deformed, you can immediately ring the warning bell that a cyclone is getting created. And the climatologists, the meteorologists are able to predict as well that this is the drop in pressure which will be expected. So, with the drop in pressure, they are able to calculate the wind speed as well. That is how you get a future prediction of the various different climatic regions, that tomorrow the wind speed will be this much, day after tomorrow the wind speed will be this much, etc. Sometimes, however, what happens in the case of the temperate cyclones, mostly, that is a rare phenomena, but it does happen. So sometimes what happens, as this front distortion keeps on happening, as this front keeps on getting distorted furthermore, the low pressure gets intensified quite rapidly, more than what the calculation will suggest to you, more than what the forecast will suggest to you. So whenever you have the low pressure which intensifies or which reduces by more than 24 millibar within one day, that is when the wind movement suddenly accelerates. The entire phenomena suddenly gets very violent. And that is what we refer to as a bomb cyclone. And the formation of that, the sudden intensification of that, is what is referred to as bombogenesis. So, this is when the destructive capability of the cyclone gets very significantly larger because the winds would suddenly get very strong. Why? Because the low pressure has reduced quite rapidly by more than 24 millibars. So that means the pressure gradient has significantly increased. That means the wind velocity will increase. So that causes a lot of destruction and devastation in its wake. So that bomb cyclone is majorly associated with the case of temperate cyclones. So bomb cyclone is a powerful, rapidly intensifying storm associated with a sudden and a significant drop in the atmospheric pressure around that low pressure. So whenever you observe or it involves a drop of 24 millibar or more of pressure within a span of 24 hours. So as a result of that, there is a sudden intensification of low pressure, kicks in a very rapid development of a cyclone, and that is what is referred to as bombogenesis or explosive cyclogenesis. genesis. That is what is associated whenever you talk about a bomb cyclone. Okay, so that is the aspect of the temperate cyclones in general. Okay, the entire cyclonic circulation can in itself be moving from west to east, and then there will be a curving or a bending owing to Coriolis force, but west to east is because of the westerly movement. And this temperate cyclone would last generally for 2 to 3 weeks. Now we come to the existence or the formation of a tropical cyclone. Tropical cyclone formed in the tropics. The formation in itself is very different. Here, no involvement of front or the frontal formation is not involved here, but here you do require a moist air mass. Moist air mass is a very important requirement here. Now, this is something that we experience across our coastline multiple times during an year. We have a cyclonic season as well. That is from the month of April, May, and early part of June, and then again November and sometimes December is when we experience this. So that is the tropical cyclone, which is associated with much greater amount of destruction, much stronger wind movement as compared to a temperate cyclone. Tropical cyclones are very, very devastating. So, what is this tropical cyclone? So, this tropical cyclone, we'll talk about the formation as well, but this gets created in the tropical waters across the tropics of the globe. So they are referred to as by different names. So if they occur in the northern Indian Ocean or in the Indian Ocean in general, they are referred to as the cyclones themselves. If the same disturbances or storms originate in the Atlantic, they are referred to as by hurricanes. They are referred to in the Western Pacific and South China Sea. They are known as the typhoons. If they develop in the region of Western Australia, they are referred to as willy willies. All of them are the same formation. The naming is different. So let us understand how they get created. And then after that, I'll tell you the prerequisite conditions for their formation. But before that, I want you to concentrate upon the basic formation. Now, by this point of time, I hope we are aware of the latent heat of condensation. Latent heat of condensation is understood? Yes? So all those who don't know about latent heat of condensation is, I had told you for the prior 2 classes. Kindly pay attention to that. So all those who are not aware of that, I'll tell you in brief. Whenever you have a vapor getting converted into liquid water droplets, or whenever there is a condensation happening, at the time when the state of matter is changed from gas to liquid or liquid to solid, heat is released. So that at the time of condensation, the heat that is released, that is referred to as the latent heat of condensation. I hope that is understood. Now, let us understand the formation of this tropical cyclone. So, traditionally, and always it will be formed only over water bodies. And again, I would reiterate, when I say water bodies, does not mean the pond or a lake in my backyard, does not mean a river in front of my house, which appears like an ocean in itself, does not mean the overhead tank. I mean large seas and oceans in the tropical water. So here, when we talk about these, so this is where it is always formed over water bodies. Why? We'll come to that as well. Always will be created only above the region of these large water bodies. Now, this gets created when the water bodies, they get heated up. This is driven by heating and temperature. Driven by heating and temperature rise. Always. So let's suppose in this region, the temperature has increased beyond 27 degrees Celsius. In tropical waters, just to give you an idea, in the tropical waters, the average temperature is roughly around 24-25 degrees Celsius. when the temperature of these waters, they start increasing beyond 27, 28 degrees Celsius, that is when an intense low pressure gets created. So let's suppose here you have the creation of an intense low pressure. So what will happen to the air immediately above it? It will rise up. Furthermore, if you have an intense low pressure created, it will attract winds from all sides. Always, low pressure will attract winds from all sides. So winds are attracted from all sides. Now, if I ask you the property of this air mass which is getting attracted, about the temperature as well as the moisture presence, what can we say about the temperature and moisture presence of this air mass which is being attracted? Can we say that this air parcel or the air mass which is getting attracted will be warm because it is the tropical waters? And secondly, can we say that it will be very moist? We can always say that. Beautiful. So here you have warm and moist air. This is warm and moist air. Now, as it gets attracted towards that low pressure, this air will also get heated and then it will start rising up, but it will never rise up in a straight wave fashion. It will rise up in a kind of a circulation. Always. Why? Because of Coriolis force. The bending will be in the anti-clockwise direction in the northern hemisphere. Circulation will be in the clockwise in the southern hemisphere. So as it starts to rise up, it will rise up in a circular manner. It will start to rise up in a circular manner. In a circle, if you can imagine, it will start rising up in a kind of a circular manner. Now, as it rises in a circular manner, what will happen to the temperature here of the air? Temperature will reduce. Now, this is a moist air that we are talking about. So, condensation will be very easy. Immediately, condensation will start happening because it is already very moist. So, immediately around that circle, as the air is rising around in a circle, immediately around that, all around that circle, cloud formation will be observed. So cloud formation will be observed around that circular rise. Are we comfortable up till here? Good. So here, the cloud formation begins to happen around that circular formation. That is where the cloud formation will begin to happen. Why cloud formation? Because it will rise up, its temperature will reduce. As the temperature reduces, the carrying capacity will reduce. It will reach saturation. As it rises up further, it will cool down further. Cooling beyond saturation leads to condensation. Condensation in upper air leads to cloud formation. Is that understood? Good? Good to go? Perfect. So now, here, the cloud formation will happen around the circle. Now, this is your rising air. This is where the air is rising. Now, when the cloud formation is happening, can we say that vapor is getting condensed? That is the cloud formation. Vapor is getting condensed. Now, around the circle, if you can imagine, let me take the help of a simple thing. So let's suppose, if you can imagine this, let's say a couple of cups here. So around this is just to represent a circle. So all around this, if you have a cloud formation which is happening all around this. Now, latent heat of condensation will be released. Every time that condensation is happening, latent heat of condensation will be released. Where will the latent heat be released? In the center, around the circular portion in the center, because all around it condensation is happening. So every time that any particle undergoes condensation, latent heat will be released. So in the center, you will have latent heat of condensation, which is consistently released. Understood this? This particular part is understood? Good. So here, latent heat of condensation is released. Condensation is released. Now, if all that latent heat of condensation is released in the central portion, what will happen to the temperature in the central portion? The temperature in the central portion, will it rise or will it fall? The temperature will rise always, right? So in the central portion, you will have a rising temperature. Increases the temperature at the center. Perfect. Now here, the center is heated up. Now, if the temperature is higher, will condensation occur or will condensation not happen? If the temperature is high temperature, does it encourage condensation or will condensation not happen? Perfect. Condensation will not happen because for condensation to happen, you require cooling. Cooling is required for condensation to happen. But in the center, heat is accumulating from all sides. So that is where it will be hotter. So that is where no condensation will happen. And consistently all around it, you have rising air. Now, I want you to recall a kind of a simple childhood experiment or a childhood mischief that I'm sure most of you would have done. Or if you have had a very studious and a disciplined childhood, which I don't expect. So try it at your home sometimes. If you ever have filled a bucket of water, and if you would have ever tried to create a whirlpool in that bucket by rotating your arm continuously and vigorously in a circular motion, I'm sure you would have observed this or you would have done this, right? Now, when that circular motion you are creating, what happens on the sides? The water starts coming out of the bucket. You would have experienced that the water starts rising on the sides. But that rising circular motion of water on the sides, what is the water level in the center? The water level in the center, does it rise up? Does it remain the same or does it fall down? Okay, it falls down. Now, air also in many of the areas has a kind of a fluidic motion. So the air all around is rising up with a significant velocity. Now, as it creates that in the central portion, what kind of impact will be created? A sinking, just like the bucket. So in the central portion, you will observe a sinking air. Created why? Because of that rise and a circular rise. Had it been a straight rise, no sinking, but circular rise. So a sinking is created. Now, as the air sinks, it is accumulating the latent heat of condensation and the warmth around it. Isn't it? It is accumulating all the warmth around it. Now, when the air sinks, does it get heated up? Due to compression, the air as it sinks into the lower region, it is forced to get compressed. So that is where it is forced to get heated up. So this air will get heated up. This air will get very warm. Now, around this low pressure, you have a warm air. So what will happen to the intensity of the warm air or intensity of the low pressure? What do you think? As around the low pressure, you have a sinking air. Now, what will happen to the intensity of low pressure? Low pressure will intensify. It will become much more stronger. So when the low pressure becomes stronger, intensifies, because it will further, that sinking air will warm that low pressure further because of the adiabatic compression, it will warm that low pressure further. So then the low pressure intensifies, and when it intensifies means what? It will attract more winds. All those winds are carrying a lot of moisture. Now when they are carrying a lot of moisture means what? More amount of rise, more condensation will happen, and the existing clouds will further spread apart, and then more latent of heat of condensation around the center. The entire process will be repeated. So over a period of time, the low pressure will keep on getting more intense, or the low pressure will dissipate. What do you think? Will it keep on getting more intense or will it dissipate? It will get much more intense. So that is how the cyclone grows stronger. And the very existence of the cyclone is initiated or conducted by what? By the presence of that moist air. If the air had been dry, that latent heat of condensation would not have been released. That intense heating would not have happened. That much amount of condensation would not have happened. That is the reason why this will never exist over land areas. This will always develop only over water bodies. And it keeps on getting much more intense. So the longer this circulation is over a water body, it keeps on getting stronger and stronger and stronger. The moment it hits the land, that is when immediately it will start to weaken, what we refer to as the landfall of the cyclone. And that is when it will immediately weaken. So that is the entire process of the formation of a tropical cyclone. Okay? Is that understood now? Perfect. So this is what is referred to as the eye of the cyclone. Eye of the cyclone. This is what is referred to as the eye wall. Okay? And this cyclone, this type of cyclone is referred to as or oftentimes it is referred to as a heat engine, because it is able to sustain itself, it is able to intensify itself without any external help. Just creation of low pressure, it will continue to intensify itself over a period of time. So that is why when you talk about it, so you have latent heat of condensation, heat of condensation, plus sinking air, will do what? Intensifies low pressure. That means what? Attracts more winds, moist winds. Means what? When more moist winds are attracted, that means you will have more condensation. When you have more condensation, then what will happen? More release of latent heat of condensation. This keeps on fueling itself and cyclone gets stronger. Gets stronger. This is why it is referred to as a heat engine. Here it is created, here you have a sinking air. Okay? Is that understood? Sinking means, I cannot explain the meaning of sinking, something which falls down, I think. Cyclones, how they are named, we'll talk about it tomorrow. Okay? So I hope this basic portion is understood. Right, yes. So I don't know if he was asking for the Hindi meaning of it or not. Anticyclone is a kind of a high pressure, intense high pressure. You can go now. I give you the freedom to go anytime that you want. Temperate cyclones can also move from one place to another. Why the air is sinking at the center of the cyclone? Because around the cyclone, around the eye, you have a circular rise of air. So a continuous circular rise of air basically means what? That around the center, you have automatically a creation of a suction. And that is where you have a sinking air. That is where you have sinking air. There is adiabatic compression. Which will further intensify the low pressure. That is how the cyclone gets stronger. That is the reason why this cyclone will always get created only over the region of the water body. Because over the water body, you will have the presence of moist air. And when you have the presence of moist air, that is when you will have greater condensation. Greater condensation means more latent heat will be released, which means much more intensified low pressure, which means more winds will be attracted. Now, will this, at the case of the eye of the cyclone, the temperature will be higher or lower? What do you think? At the eye of the cyclone, the temperature will be higher or lower? It will be higher, because at the eye of the cyclone, significant amount of heat is produced in the process. So that is why, and I hope we are aware that in the eye of the cyclone, because it is hotter, so it will be cleared sky. It will be lack of cloud formation, which will be observed there. Okay. So that is the aspect of the tropical cyclone. Okay. Right? Good. How will it end? The the reason it will end, or the moment it will end, is the moment it will hit the landmass. That is when it will come to an end. Okay, the naming of the cyclone is something that we will study tomorrow. And then for tomorrow, what I want you to do is, I understand many of us, we are not even aware about the entirety of the stretches of the Pacific Ocean, Indian Ocean, etc. So look at what is the eastern extent of Indian Ocean and what is the western extent of Pacific Ocean, which are the regions on the west of the Pacific Ocean, which are the regions on the east of the Pacific Ocean. Do look at that, have a revision of planetary winds, and then we will be able to cover the portion of El Nino, La Nina circulations. That is going to be relevant for you in order to understand the portion of Indian monsoon that we are going to cover on Friday. That is going to be very, very important topic for the entirety of geography. So the entirety of climatology that we are studying is with the goal to understand the Indian monsoon. Map pointing, as of now, I just want you to revise these portions that you have studied. As of now, just take up that task. Tomorrow, I'm not going to repeat the entire formation of a tropical cyclone again. Regardless of whatever you will say, I am not going to follow the entire process again. I'll tell you in brief, but then we are not going to do that over again. So revise this, understand this, come prepared tomorrow. We will carry it on further. Okay? Gulam, one fine day, maybe. Small sample of cyclone are formed in Rajasthan of sand. No, that is not a cyclone, my dear friend. That is what is referred to as a dust devil. Are you talking about this? In a small patch, you have a circular rise of sand that you observe. That is not a cyclone. That is what is referred to as a dust devil, created again due to intense heating. Okay. How do we come to know that this front is going to become a temperate cyclone? That is dependent upon the pressure difference and the energy that the winds have. Are eye walls, as eye walls are there, clouds always really, eye walls are very, very dense. If I show you the satellite image that we have seen, these are your eye walls. This is the eye. Eye is always having a clear sky. Rain bands here that you observe, these are in circular motion as the clouds get created. So these clouds get pushed aside as and when more evaporate or more condensation will happen. So the older clouds get pushed aside. So those chunks of clouds which are pushed aside, they form the bands of rain, significant cumulonimbus. These are your rain bands. How to create a bomb cyclone? Well, we humans, we cannot create a bomb cyclone. It is basically formed when you have a sudden drop in that low pressure, which gets created primarily and majorly due to the factor of temperature also getting involved in the frontal formation. Anticyclone is a condition of extremely high pressure where from all areas you have air sinking in one region, and high pressure is a region where the winds will move out of the high pressure. Low pressure is where the winds get attracted. So that is your anticyclone, from where the winds will get pushed aside. Okay. In stage 3, how cold air comes on warm front? Because when you talk about the warm front or the cold front, always on the ground, only the cold air will remain. The warm air will always be pushed upside. Temperate cyclones can happen on both land and sea, whereas tropical cyclones will occur only on sea. Sinking air, Mayank, when you have a sinking air, so sinking air will carry on the heat from the latent heat, and that sinking air is formed. Why? Because consistently around it you have a rising air column in circle, so that creates in the center portion a kind of a depression. So that sinking air, as it is coming to the ground level, it will get heated up due to the adiabatic compression. So that heat will further heat up the sea surface and will intensify the low pressure, which will attract more moist winds, which will end up further intensifying the cyclone. Okay. Does anticyclone then cause any rainfall? Absolutely not. Why will the anticyclone cause rainfall? It is a region of a high pressure. And in the case of temperate cyclones, why do warm air from subtropical high pressure get dominated by the cold winds? So it is always going to be the case that the cold winds are going to stick closer to the ground, warm air is going to get uplifted, and you have a thermal high pressure driving those cold winds, dynamic high pressure driving those warm winds. A thermal high pressure is always going to be much stronger. Formation of an eye wall, basically around the circular rise, that is where the condensation will keep on happening. So that is where the condensation can happen right from 2 kilometers above the ground surface to around 10-12 kilometers above the ground surface. So that is where it will have the maximum amount of condensation happening. That is where you have the dense eye wall. Why do tropical cyclones weaken after landfall? That is because as they make a landfall, their access to moisture. Moisture is a warm wind, and moist wind is very important for this. So as they make landfall, their access to moisture is cut off, and that is when they will start dissipating. Okay. How much can eye of cyclone be warmed? So generally it is around 4-5 degrees higher than the surrounding regions in general. Okay. And reasons for continuous, there are multiple reasons for rainfall nowadays. It is the monsoon season. Monsoon season always is associated with rainfall. Diameter of eye wall, if you take a look at it, It is generally around a few kilometers, sometimes 10 kilometers and more than that. So whenever the eye wall comes, you have a clear sky. Sinking air comes from the surrounding. Can we say tropical cyclone which emerge farther from land in the ocean are more devastating? Yes, absolutely, because they spend more time over the sea. What is the average height of temperate cyclone and tropical cyclone? So the average height, see, the cloud formation can happen in both the cases. Wherever cumulonimbus clouds are there, they can start to happen from the region of 2 to 3 kilometers from the ground surface, right up till, in certain cases, up till the tropopause. Okay, but tropical cyclone will have much thicker cloud formation. Why sinking air? Again, do one thing. All those who cannot understand the aspect of sinking air, fill a bucket of water, start rotating your palms and hands and forearms in that bucket to create a very strong whirlpool. Observe what happens in the sides. You will observe that the water, as it starts rising up, it spills out, and in the center, it simply sinks. So as in the center, the air sinks, it will get compressed due to adiabatic compression. Adiabatic heating will happen. That adiabatic heating will lead to intensification of the low pressure. Since there is zero Coriolis force on the equator, then there is a direction of the cyclone in equator. So in equator, no tropical cyclone gets created. Why anticyclones are black in the center? So that is the image. Not all the anticyclones are black in the center. That is a representation which indicates to you a clear sky, a presence of a clear sky. Okay. Yes, Lakshya. So that is where we'll end the session here today. We meet again tomorrow, where we shall again be revising, recapping this very briefly in the first 10 minutes of the session. We'll be talking about the portion of the naming of the cyclones, why it is that the naming was required, what are the aspects involved in naming, and then we shall be moving ahead into the portion of Walker circulation, ENSO, jet streams, Indian Ocean dipole, Madden-Julian oscillation, all the complex atmospheric phenomena that you have been hearing around in the newspaper headlines. That is something which we shall try to understand in greater detail tomorrow. And then after that, we shall be proceeding ahead day after tomorrow into the portion of Indian monsoon. So that is all from my side here. I hope the session has been understood. Try to revise this. The less that you revise, more difficult it will be. Please try to revise it. And if you revise it from the lecture first, that is where the concept clarity will happen. That is a given for sure. And we meet again tomorrow. Take care of yourself. Goodbye. Thank you.